Hey, Pre-Algebra. Here's the last sample proof for the Pythagorean theorem that I'm going to have you do. I have a few more if you want to look at them. For example, here's one that involves a trapezoid. This one's pretty interesting. You guys can give that a try if you want. You can ask me for that. And then there's another one that uses similar triangles. So, where is that? Right here. This is the one that's using similar triangles, and so it's proving that these are a little bit more difficult, the trapezoid and the similar triangles. So we'll just stick with Sophie's method here, and we'll end it here. This is an important one that I want you guys to really pay attention to, because it teaches you something very, very interesting. Number one, we've got a triangle A, B, and C. A and B are the legs of the right angle triangle. It's hard to see, but there's a right angle there. What they did is they then made a square outside of the A, made a square outside of the B. Then they used this diagonal line to make another triangle. And the idea is area of the small squares is A squared and B squared, and the area of the big square is C squared, which should be pretty obvious. And her claim, Sophie's claim, is that C squared is therefore equal to A squared plus B squared. And the only hint that she gives us is 4 triangles. So what I want you to do is I want you to pause the video right now. I want you to take a look at this and try to figure out what is she trying to say. Think about what kind of triangles she's using, and then is her reasoning convincing? So go ahead and pause it right now, and I'll continue this video in just a few seconds. Okay, so I went ahead and drew it on a piece of my green paper here. What she's trying to say is that the area of this is A squared. This is A squared. This is B squared. And the area of this is C squared. And her only thing that she said is that this A squared plus B squared is equal to C squared because of 4 triangles. And if you're able to get this, good job. If not, that's totally fine. This is not a very well done proof. She's got 1 triangle here, 2 triangles here. That's the A squared. She's got 3 triangles here, 4 triangles here. So the A squared and B squared, it has 4 triangles that are all equal. For C squared, she's got 4 triangles as well. And these are all the same size. All 4 of these triangles on each side are the same. So the 4 triangles for A squared and B squared are equal to the 4 triangles for C squared. And that is her proof. What I really want you to pay attention to, though, is what kind of triangle is she using? Because all of these methods that we've been going over so far, it's supposed to be true for any A or B or C. As long as it makes a right angle triangle, these proofs should hold up. And this works, but does it only work for her type of triangle that she made? She made it so that A and B are the exact same length. A and B, by necessity, creates 4 triangles that are all the same, because she said A and B are the same length. What happens if we were to change up the triangle just a little bit? What about instead of A being this length and B being that length, let's say B is twice as long. Right, like that. Now I've done the exact same thing, but hopefully you can see what's wrong here. There's something very, very important wrong. This triangle and this triangle are the same, but these two are different sizes. And then this triangle is not the same as any of these. So I can't just say, oh, look, there's 4 triangles here. those must be the same as these 4 triangles. It ends up being that way, but it's not proved this way. These triangles, this green triangle here is not the same as these triangles here. So you have to come up with a different way to prove it. You'll have to come up with something else. And I'm not actually going to require that you do this because it's pretty difficult to do this. It is true that these 4 triangles do add up to these 4 triangles, but because none of them are the same size, it makes it a lot harder. So if you want a challenge, go ahead and try proving that a squared plus b squared is equal to c squared using only this, the 4 triangles method. It's difficult, especially because you don't know the heights of these triangles. So that's Sophie's method. So what I really wanted you to get from this is the answer to number 2. Is her reasoning convincing? To me, it's not. It's not, because she used a very specific type of triangle and it only works for that type of triangle. So go ahead and try to explain how she could improve her proof, if you can. And then we're done. We're done with the Pythagorean theorem and proving it. So have a good one.